All right, well, welcome back to the week before Thanksgiving. Let's go ahead and start off with Project 4, preview for Project 4. No, this is Project 4. Oh, what do I say preview? Oh, anyways, for this project, we're trying to find the minimum overlap of sets that still cover all points. You all got that?
That's too much discrete terms.
For example, say we have multiple group projects for our class that need to be graded at the end of the semester. Let's just say we have 1,000 students, just to make things interesting, and we all have group projects. Okay. Your professor must grade every student at least once. Note, I don't have to grade every project. I just have to issue a group grade or a grade to every student. But we want to minimize the number of total grades that the professor must perform, because even though you're in a group project, I have to grade you based each one of y'all individually as opposed relative to the group. So I want to minimize the number of total grades I give out to students, not the number of group grades. The number of student grades is what I want to minimize. Your professor does not mind grading multiple projects, but due to the nature of projects, students are members of multiple projects. Oh. Okay, so you can be a member of multiple projects, but only want to present once. Okay. How can we minimize the number of times a student has to present or that a professor has to grade? They turn out to be effectively the same question. Everyone in a group has to present. There's no partial group presentations. And a grade must be assigned for each group member. I don't grade just part of the grade. In other words, I have to grade the entire group or none of the group. It's all or nothing. To recap, oh, and again, I'm trying to minimize the number of grades out, or we're trying to minimize the number of student presentations. It's the same question. To recap, here's a little more in-depth. Each student will be issued an ID number. That's right, you're all numbered now. We do not care about their names. Get over it. Each group consists of a set of numbers. Keep in mind that a group cannot have the student in there more than once. Everyone okay with that one? All right. A query consists of a group of numbers. A student must be in there. A student may be in there more than once because maybe I misplaced a grade and I have to grade a student more than once, maybe twice or 3 times. So the query are the grades left that I have to perform. And we have a bunch of groups with all the students in them. When a group presents, all students are graded. Your function returns the minimum number of grades your professor has to assess. I don't care which groups you select. I just want to know the minimum number of grades that I have to assess, or the minimum number of students that have to present, whichever way is easier. If it's not possible, return UInt max or -1. They're actually the same. So there might be a situation where I need a grade student 3 times, but he's only in 2 groups. It's not possible. All right, each file. All right, let's just jump over to the code real quick. All right, so we're inside Project 4. Let's jump into data real quick. I have a lot of different sets. Let's open up simple set. What this is these are the groups that can present. So the first group consists of students 0, 2, and 4. The second group is students 0, 2, and 3. Third group is just 1, student 1. Then fourth group is 2, 3, and 6. Fifth group is students 1, 4, and 3. And the final group is just students 5 and 6. So those are the groups that can present.
Projector's out.
What's that?
Projector?
Oh, the projector's messing you up? Oh, it died. Oh. No, it's back. At least on the screen? Okay, good. All right, so those are the groups. So if I need to grade just student 1, the answer would be 1 because we can just grade this one. We don't need to use this whole group, which would be 3. We can just use this one. If I say I need to grade, what am I going to say? Let's actually jump over to the example. So the minimum, if I need to grade 0, 2, and 6, the answer is 5. By the way, here's that set file again. The answer is 5, which represents 0, 2, 5, and 5, 6 for a total of 5. And there isn't another combination that we can do to minimize the number of grades. Minimum of 1 is 1, great. Minimum of 1, 2, 2, 3, again, 2 can be in there twice, is 7, because what do we choose? I think we chose this one. Sorry, this one here, what was the other one? 1, so then this guy, which would be 7. Note that we could have also chosen the first one as well. It doesn't particularly matter because I only care about the minimum amount, not which groups you choose. You have an idea? Yes? Oh, question? No. Is this making some sense? All right. Let me scroll back up. Each file in the data directory contains sets, except for the data.plat, which represents the groups that may present. The CPP file is a general purpose test program for running your code. It also does produce timings. Minimum overlap is the header file, of course, and we got the CPP. Data simple.set is the example set provided by below. All of y'all should be able to get this one done. Small 30 is a set for evaluating basic timings. I have minimum 30, large 30, and large 50. And large 50 represents the largest data set I will test. So I give you the data sets. I'm not going to give you the queries. All right, interface, minimum overlap. I will pass in a string pointing to the set group file. There's only one group file that contains all the groups, so you just have to deal with one. I'll put your constructor so you can do whatever pre-processing you want at that moment on those groups. So I'm giving you the group. I'm not grading your pre-processing of the group, so you may pre-process as much as you want. But keep in mind, if it does take an extremely long time, then I will take off points. Okay, so I lied. I'm not grading the overall performance. I'm only grading if it takes too long. What's too long? 5-10 minutes to pre-process a simple small 30. Yeah, that's way too long. Don't be doing that. This is the one that I care about performance, find minimum overlap. I'm going to pass in a vector of the cover, aka the students that need to be graded, and then a print. That just is a helpful testing tool in case you need to print. I would put some if statements, if print, print off a bunch of debug stuff to see what's going on. Okay, let me jump back over and show you how this runs. So you make, still in Japanese. Can I change the language? I forgot to change the language. Sorry, guys. So if you just run it, it says the set file, yes, no, and the list of phrase. So if I do minimum overlap, let's see, data simple.30, yes, 0 to 6. I think it's segfaults. It does segfaults. Huh. But the idea is that it would send to your constructor, so it does time how long it takes to pre-process, and then it's going to test a cover, and it should give you an actual answer, not a segfault. I'm going to jump down a bit just to show you some runs down here. Oh, that's tiny. So if I were to run minimum overlap worst, hey, this was the worst case scenario. Simple.set, yes. And here are these queries. Arguments are validated, calling constructor. Testing cover, found a minimum of 6. So here you go, I actually give you some answers and some timing. Down here I did small set 30 for the 60-point solution. This is how long it takes for each of those. On my machine, which is an older i5, chances are you have a faster one than me. And here's some timing for 30, so forth and so on. Okay. Let's jump back up. Oh, make at least a little sense about how you use it. If you just passed in this, it should output basically this. Of course, the timing will be different depending on how fast your solution is. We good so far? Okay. So how do we solve this problem? All right, there are different ways to solve this problem. For this project, you are to use recursive backtracking. That is just to make everyone's life a lot easier, at least for grading in my view. There are other ways to go about it, but for now, just use the recursive backtracking. It'll be the most helpful, at least moving on, learning recursion and how everything works. So the algorithm setup. So this is the algorithm down here in pseudocode, but let me describe the variables. So find minimum overlap. We have so far, input, and then a print. Notice already that in the header file, we just have a cover and print. So you're going to have to already translate it from this function call to the recursive function call, which hopefully is not too hard. It has 3 parameters: so far, input, and print. I have not defined the type of so far, and I'm not going to because that's up to you. So far represents the sets that you have chosen so far. So in other words, in the beginning, so far, or chosen might be a better word, is empty. Input represents the IDs that you still need to choose from. So to choose. Print is for your convenience. You can ignore if you want to, but I recommend printing debug information if print is true. Min represents the minimum number of overlap found so far. Notice I set it to U max. So aka we haven't found anything. And result is what's left over from removing the evaluating set. Okay, we'll get to this in a moment. So real quick, how does this algorithm work? Let me see. So we start off min is Umax. We're going to go for each set S in the set file. In other words, this for loop is going to iterate through every group that's in the group file. In other words, let's jump over to here. Go to data. Let's open up simple.set. It's going to iterate through each one of these. First here, then here, then here, then here, then here, then here. It's iterating through the different groups. Okay. And if you look at it at the end of the for loop, we just return min, which implies that hopefully min will be manipulated somewhere in here, but if it's not, then you're returning umax int, which means there's a failure. Okay. So we're iterating through the sets. What do? We first compute result. Result is input subtract S. Okay. I'm writing it this way, because again, it's up to you how you want to do this. But you take your input, aka all the students that still need to be graded or chosen, and you subtract S from it. Namely, take away the students that are in that group that you're evaluating for. Aka, let's pretend like we chose this group. What are we going to do? Well, first off, if so far has 0 members, that means we found a cover. Then if has fewer members than min equals the size of so far plus the selected S. And then we can continue on the loop and iterate to the next. It looks like must be an old file, because right here you need to add back what you, well, no, you don't. I lied. Ignore that. Okay, so min is size plus so far, and that's our current min. And then we continue on, and if you look at what's going on, since we're recomputing result each time, we're actually evaluating choosing the next set S and ignoring what we did previously. So we don't have to add back input because we're recomputing result. Does that make some sense? Yeah, okay. So in this happy case, we just update min and we continue on. But if result does not have 0 members, we add S to so far, aka the set we're looking at. Then we recurse. We call our function again because we've added so far with the result this time as input, because remember, result's what's left over, and then passing along print. And then that's going to recurse and get an answer. If cmin is less than a min, then we update our min, and then we remove S from so far so we can evaluate the next S. So it's important here that here we add it to so far, and then here we remove it if necessary. And then we can continue on. And then we return min when we're done. In other words, this algorithm is going to evaluate every possible combination there is and return the minimum once it finds it. What do you think the big O of this is?
N? Oh, maybe not. Square.
It's not. N squared. Well, it would be N squared if you were just looking at the ones before. But if you notice it, when you recurse, you start from looking at the ones previous as well, again in combination. So this one ends up being an n factorial algorithm. Ooh. So your job is to try and minimize this a bit, or as much as possible. There are a lot of tricks. But y'all understand the general algorithm? I have some yeses. You'll ask me more later?
I hope so.
Okay. As usual, we may not change the public interface, but you may add private data. By the way, you are allowed, if you want to add a couple more parameters to this function. That's fine. The one you can't remove or change is this one up here. So you can add all the stuff you want here. Keep in mind that find minimum overlap is going to be called multiple times, while your constructor, of course, is just called once. As usual, we may not change the public interface, but you may add any private data and methods. Since we're using recursive backtracking, you must add at least one additional method for the recursion to work. That's what I showed you up there. Keep in mind the above is pseudocode. I never defined what so far's type is. And let's see, notice the data stored in private section should not depend on a particular call because find minimum overlap is going to be called multiple times. Other data should be declared locally within minimum overlap and pass these parameters as needed, if that helps. Pass by reference is faster than pass by value for any data items bigger than a single integer, so consider using that if you don't change the value. Keep in mind that const does give some performance improvement, but not much. I actually recommend nowadays the compiler is going to take care of that for you once you turn on optimization, so don't even mess with const anymore, unless you really want to play with it. You may create as many helper classes as you would like. The public interface of those is completely up to you. In particular, you will need to have a representation, possibly a class or struct to represent the set or group, or maybe you'll use something from the STL. That's up to you. Oh, you may use anything from the STL on this one. I'm not limiting it. They don't have this algorithm in algorithms, so go ahead, have at it. Use the whole STL for this one. Of course, if you want to write your own, go ahead. All right, I gave you some example runs. I showed this earlier for some different point solution. I have the range on this one. Again, I've seen low as 60 points, and I've seen as high as 140. Yes, I have a 140 point solution for this one. So the range for this one, is very wide. Also, just FYI, the amount of code does not necessarily make it better. The 140-point solution was less than 100 lines. You just have to know how to use of course, that programmer used the STL like crazy, which is fine, perfectly fine. He knew how to do it. But yeah, just so you know, this is more about thinking about it and less about typing as much code as possible.
Is that person in the ACL?
Not right now. He graduated. Memory leak. Make sure you run Valgrind. If you use everything from the STL, then you probably won't need to worry about memory management because STL will take care of that for you. It's due December 6th as the official last day of class for this semester, so that's when it's due. Notice that is past the due date of where I accept late work, so this is a hard deadline. There's no minus 20% if you turn it in on December 7th. It's just a 0. So make sure you get that in, okay? All right. Any questions? Comments? Screens? Oh, okay, there. Got at least one. All right. I'm happy now.